We're now going to have a look at equivalent fractions. You can see we've got 4 circles here. The first one has been divided into 8 equal parts, the second into 6 equal parts, the third into 4 equal parts, and the last into 2 equal parts. Now you can see the first circle, 4 of the 8 parts have been shaded, so we get 4 over 8. In the second circle, you can see 3 of the 6 parts have been shaded. In the third circle, you can see that 2 of the 4 parts have been shaded, so we get 2 over 4. And in the last circle, you can see that 1 of the 2 parts have been shaded, we get 1 over 2. And you can see the value of all these fractions is equal to a half. And you can see, if you look at these circles, a half of the circle has been shaded. Now let's have a look at how we form equivalent fractions. We can form equivalent fractions by expanding, that is multiplying, or by reducing, that is dividing. Now we're going to have a look at both cases. In the first case, we're going to have a look at how to expand fractions. Now you can see here we've got 3/4. If I multiply the top and bottom by the same number, which is 2 here, I will get 3 times 2 is 6, 4 times 2 is 8. So 3 over 4 equals 6 over 8. Here, this example, we've got 2 over 5. If I multiply the top and bottom number by 4, we get 2 times 4 is 8, 5 times 4 is 20. And here, 9 over 20, I can multiply top and bottom by 5. I get 9 times 5 is 45. 20 times 5 is 100. Now, the important thing is when you expand fractions, you must multiply the top and bottom by the same number. And actually, when you have a look at this, you can see that 2 over 2 is actually 1. 4 over 4 is 1, and 5 over 5 is 1. So what you're doing is you're multiplying a fraction by 1. And so you're not changing the value of any of these. All you are doing is just changing the top and the bottom number. Okay, now expanding fractions can be useful for finding the top number or the bottom number of a fraction. For example, we're going to have a look at how we find the numerator or top number of a fraction. For example, if we've got 2 over 5 equals something over 10. How do we find the top number here, the numerator? You can say to yourself, what number must I multiply 5 by to get 10? And that is 2. So 5 times 2 gives 10. I must also multiply the top by 2. So 2 times 2 is 4. What this means is 2 over 5 equals 4 over 10. Let's use another example. 3 over 8 is equal to something over 32. I need to find the top number here. To get from 8 to 32, I must multiply the 8 by 4. Therefore, I must also multiply the top number by 4. So 3 times 4 gives 12. Therefore, 3 over 8 is equal to 12 over 32. Now, also you can use this idea for finding a denominator, and as you can see here in this example. For example, 5 over 8 equals something over 30. To get from 5 to 30, I must multiply the 5 by 6. So 5 times 6 is 30. Therefore, I must multiply the bottom by 6. 8 times 6 is 48. It's the same idea. Okay, so to form an equivalent fraction by expanding to a specified denominator, this is what we do. We find the number that does the expanding by dividing the original denominator into the specified denominator, then multiply it by the numerator of the original fraction. And this number that does the expanding is called the multiplier. So if we have a look at here again what this means, if we've got, for example, 4 over 9 equals something over 27, you can see we divide now the 9 into 27, which is 3 times. 3 times 4 gives 12, and that's what this here means. So we divide the denominator into the denominator here and multiply the result by the numerator here. Now the number that actually does the changing is the multiplier. So because we multiplied the 9 by 3, I multiplied the 4 also by 3. This number 3 is called the multiplier. Okay, now let's have a look at reducing fractions. Now, fractions can be reduced by dividing the numerator and denominator by the same number. The value of the fraction cannot be changed because the whole fraction is divided by 1. Okay, so what this means is this. If we, for example, have 12 over 18, I can reduce or simplify this fraction by finding a common number that divides into the top and the bottom. Now you can see there are actually many numbers that will divide in the top and bottom. Now you can see that 2 will divide into 12 6 times. 2 will divide into 18 9 times. And so we get 6 over 9. Now you can see here also 3 will divide into 6 and also into 9. So 3 into 6 is 2 times. 3 into 9, 3 times. And so we get 2 over 3. Now that process is called simplifying or reducing. Now you'll notice that we did this reducing from 12 to 18 to 2 over 3 in 2 steps. What we could have done in one step was find the highest number that divides into the top and bottom. That is, the highest number that divides into 12 and 18. And that number is 6. And I can go 6 into 12, 2 times, 6 into 18, 3 times. And we get immediately our simplified fraction. From there to there, instead of doing 2 steps. So the process of reducing or simplifying fractions is to find the largest number that divides in the top number and the bottom number. And that number is called the highest common factor, HCF. So for example, if we have 20 over 24, we find the largest number divides into 20 and 24, and that number is 4. So 4 into 20 is 5 times. 4 into 24, 6 times. And that is how you simplify 20 over 24. Now let's do one more. Let's do 27 over 36. Okay, so let's simplify that. Now, what's the largest number that divides into 27 and 36? What's the highest common factor? It will be 9. 9 into 27 goes 3 times. 9 into 36 goes 4 times. So 27 over 36 is reduced or simplified to 3 over 4. Okay, so let's have a look here. Reducing fractions is the same as simplifying fractions. So fractions can be simplified by finding the largest number that divides into both the numerator and denominator. This number is called the highest common factor. Now, if there is no common factor, then the fraction cannot be simplified and it's just left as is. Now, when doing a question, and where possible, all fractions must be simplified before continuing on with any calculation. Why? Because simplifying makes numbers smaller. So dealing with smaller numbers minimizes calculation errors. So please remember this because that's very important. Okay, now we're going to use this idea of expanding and also reducing fractions to add and subtract fractions in the next section.